Yep, this is Mr. Green.
I say to myself, you're such a lucky
Yep,
guy
this is your Algebra 2 class.
to have a girl like her. It's truly a dream come true.
We're taking up an interesting topic today.
Best in the world, she belongs to you. But it was just my imagination once again running away with me. It was just my imagination running away with me.
That's it. We're going to let our imaginations run away with us today. And we're going to take up a topic, a math topic, an Algebra 2 topic. But it's all just imagination. What? What? Yeah, I don't want to ignore the things I need to be telling you. Due dates, you got to get things turned in. If you don't get them turned in, we'll be, they're going to get zeros and they're going to be remaining in your grade book for a while. That's really bad for a grade. It really, really, really is. You need to make certain you get those grades into me, okay? So, where are we? We're taking up imaginary numbers. And see, here, 8 is talking to 2 and 3. It says, hey, you guys want to meet my new friend? 2 and 3 say, sure, where is he? He's right here, according to 8. Why can't anyone else see you? And he says, beats me. Uh, you'll have to understand what an imaginary number is here real quickly. So we're going to simplify radical expressions that involve imaginary numbers, and we'll learn to add, subtract, multiply, and divide these imaginary numbers. Oh my goodness, imaginary numbers. What are they? Well, all this time we've been talking about solving parabolas every once in a while. And when you start talking about solving a parabola, there's always been one equation that I've avoided, and every teacher avoids it. It's this one right here. X squared is equal to negative 1. If I take the square root of negative 1, I get, oh, you can't do that. Calculator doesn't like that. It blows up and gives you a big time error. That's because the calculators can't conceive of a square root of a negative number. That's because it's imaginary. Okay? Well, mathematicians knew there had to be a root there somewhere. It just couldn't be that you can't find the square root of a negative number, so they came up with a new way of doing it. And since it's imaginary, we can't really see it, we're going to start calling it I. That's it, just the letter I. That means the square root of negative 1. See it right here? I equals the square root of negative 1. That's what that means. That is what the imaginary number is all about, is the square root of negative 1. Anytime you see that I, square root of negative 1. That's what it's meaning. Okay? Very simple. So if I'm looking at something like this, I'm going to pull the same trick that I always pull with these. I'm going to factor the 25 into 5 times 5, or 5 squared, right? But I've got this negative number there. So it's going to be the square root of negative 1 times the square root of 5 squared. Well, 5 squared factors out into 5, and negative 1 square root of negative 1, that's I square root of negative 1. There's my simplified form of a square root of negative number. Okay? Well, let's look at this one over here. 48, that factors into 4 times 12. Well, 12 actually factors into 4 times 3. So what do I wind up with? I wind up with 20, because the 4 came out, 20 times the square root of negative 1 times the square root of 3. Okay? This is really simple. Negative 1 is going to be I. So this is going to be 2I square roots of 3. Wow, Mr. Green. It's imaginary. You can only imagine it. Yeah, you can never really imagine where it came from. Okay? So let's look at some some things here. If I'm going to be adding, I'm going to treat I like it's any other variable, like it's an x, a y, a z, anything else. I can't add it to something that's different from it. So what I'm going to do, if I see something like this, is I'm going to factor it out. Factor the I out, and then add the two values that are in between here. If I'm subtracting, I'm going to factor it out and subtract the two values that I get. If I'm multiplying two imaginary numbers, I'm going to multiply the x times the y, and I'm going to multiply the I times the I, because that's I squared. Well, what does that give me? I squared is -1, because the square root of I is square root of -1 is I. Square both sides of it, and you get -1. Okay, so I get x times y times -1, or -x times y. What about if it's just a number times xi? Well, I'm just going to multiply the two numbers together and leave the I there. What if I'm dividing? I'm going to divide the i's because they'll cancel out because they're just any other variable like anything else, and it's x divided by y. What if I'm dividing by a constant into it? I'm going to divide the numbers and leave the I there. Let me try a few of these. 15 plus 25, that's 40 times I. How did I get that? I factored the I out. That'd be I times 15 plus 25. Well, that's where I got the 40 from. 15 plus 25. And it's times I, 40I. How about this one? I'm going to factor the I out again. And I'm going to get negative 0.07, or negative 0.7 minus 1. Okay, that's a negative 1.7 I. Here's the multiplication. I'm multiplying 25 or 5 times 15. That's a negative 75 I squared. Well, you know what? I squared is -1. -1 times the negative gives me a positive. So this would be a positive 75. That's a 7, by the way. Yes. Up here, I got 21 divided by -7. That's -3. And I've got an I, -3I. That's how those are done. Okay? Not really a problem. We can get this accomplished. Okay? Now, this is saying, trying to let us know if we're adding things with imaginary numbers in them, like we added over here, our addition is always going to still wind up with an imaginary number in it. That's what we mean by closed. Okay? That means if I started with imaginary numbers and I add something onto it, I'm going to wind up with an imaginary number. But if I'm multiplying, is that one closed under multiplication? Well, we got an example of that right over here. If I multiplied two imaginary numbers together, I got a number, a positive number. No negative in it, no I in it. So guess what? Imaginary numbers is not closed under multiplication. You could multiply and get something that's not an imaginary number. So that's what we mean by the word closed, and what we're talking about here with imaginary numbers in addition and multiplication. Okay? Moving forward. If I'm looking at powers of I, and I just did one over here real quickly, I said I squared was equal to -1. We should be able to see pretty easily the I to the first power is I to the second power is -1. Get my pointer out here so that you can see where I'm pointing, is -1. I to the third power, that's I times I times I, or -1, because I squared times I, that'd be a -I. And I to the fourth power is 1. Now that's all four of the possible combinations. So if I'm looking at I to the 5th, 6th, and 7th, or 5th, 6th, 7th, and 8th, it's just a repeat of the same values, isn't it? Because every time I get I to the 4th, I'm going to get 1. 1 times anything is 1. Times anything is that number. So if I'm looking for I to the 15th, one technique to do this is just keep counting. Well, there's 1, 2, 3, 4. There's 5, 6, 7, 8. I'm going to count down. 9, 10, 11, and 12. Those are going to be the same things as what you see there. So 13, 14, and 15 would be right here. I to the 15th is equal to -1. How about I to the 21st? Well, there's 16 there. I could keep going. 17, 18, 19, and 20. So 21 would be this one up here, 21. That means I to the 21st is actually equal to I. So we're going to be reducing these things down simply, getting rid of the powers at every chance we get. Okay? Well, what if they're in the denominator like this? What are we going to do? It's real simple. You can just subtract them. What? Well, this is going to be 3/4 I to the -7th, right? Well, every time we get a 4, we're going to be able to take it out. So that's going to be, let's see here, this is 1. Be the same thing going backwards. -1, -2, -3, -4, -5, -6, -7. That'd be a -I. Guess what? This one is going to be 3/4 -I. Oops, it's actually in the denominator, so to the -1st power. That would be my answer. Okay? This one over here, I can see there's 6's in these things here, so I'm going to eliminate those real quickly. I'm going to get 2/3 again. 2/3. I'm going to subtract the 6 from the 5, and I'm going to get I to the -1 power. What's I to the -1? Just leave it like that. That would be my answer. Would I put it in the denominator or put it in the numerator? I would leave it in the numerator. Okay? Now, some people like to rationalize these the same way they do square roots. So in this case, it'd be -3 over 4i. And what they tell you to do is to go ahead and multiply this by I over I. And what this is going to do is give you a -1. So that's going to take care of that one, and you'll get a -3i over 4. I think it's going to, I'm sorry, you get a +3/4 I. I think that and this are exactly the same thing. Doing the same thing with this one. Multiplying it times a -I over I, I'm going to get 2i over -3. So -3. And that would be the rationalized version. So first things I did was 1, simplify it, and 2, rationalize it. Just like we did square roots. Okay? Let's move forward here. If you have questions about this, and I'm sure you will, because I want you to know, imaginary numbers are only in your imagination, and if you can't imagine it, it's difficult to conceive it. You need to come and ask questions at Toga. Please do, because I am going to be there to answer your questions. I want you to come ask questions, make certain you understand how to work with rational numbers. I appreciate you telling me that you're in Algebra 2 every time you communicate with me. It helps me find you quicker and answer your questions. I'm looking forward to seeing you